Okay, the graph represents how displacement varies with time for a vehicle moving along a straight line, during which time interval does the acceleration of the vehicle have its greatest numerical value. Okay, you should be able to read the displacement time graph. Right? Velocity is equals to the gradient. A and D is part A, is part D, stationary. C and E, uniform. Right? Uniform velocity. That means no acceleration. These two parts. So the one that is changing, the slope is changing now. Where there's a curve, the slope is changing. So B is the region where the velocity changes or increasing. Answer is B. Can? Anything that is not clear? You are muted, so I cannot hear you.
Oh, yeah. Good.
Okay, Okay, let's go to number 8. You won't bother about this one. A racing car accelerates uniformly through 3 gear changes with the following average speed: 20 meters per second for 2 seconds, 40 meters per second for 2 seconds, and 60 meters per second for 6 seconds. What's the overall average speed of the car? Right? The thing to remember is in this case, what is the answer?
D.
Okay, let's see. Right, first you have to calculate the total distance traveled and then the total time. Donkey. So distance equals speed times time. So total distance 20 times 2, 40 times 2, 60 times 6, add them up, 480. Total time 6 plus 2 plus 2 is 10. So 480, 48. Can?
Oh, total distance divide time.
Total distance divided by total time.
Okay.
What's the next question?
Wait,
11, 12.
Question 11.
Okay, question 11.
Put C.
A body starts from rest at a time t equals 0 and move with a constant acceleration. S is the displacement. No, C is wrong.
Oh, constant acceleration.
Ah, which graph? This one is memory
B.
work. B, B, parabola. Number 12, can do. Passive question.
B.
Okay, let's see. Object travel at constant speed of 10 meters per second for 10 seconds. During 5 seconds, it accelerates uniformly to 20 meters per second. Okay, uniform velocity, uniform acceleration. You should be able to read. What's the total distance travel? Right, total distance. You can divide it in the way you want to. Right, area under the graph. So it's area of rectangle plus area of triangle. Area under the graph, area of rectangle plus area of triangle. The area of rectangle is 15. This is 15. This is 10. Area of triangle is half. Height is 20 minus 10. 20 minus 10. Base 15 minus 2 minus 10. 15 minus 10. The answer is B. Okay. You say B, isn't it? So correct. No?
Yep.
So the next one is number 18. Lah. Usually it's better to draw a graph. Lah. Sketch a graph so that you can understand what is happening.
I put C.
See. Okay, let's see. A goods train passes through a station at a steady speed of 10 meters per second. That's a goods train, 10 meters per second. And the express train at rest, express train at the station. The express train leaves the station with a uniform acceleration given just as the goods train goes past. Both trains move in the same direction on a straight parallel track. How much time passed before the train overtakes the goods train? So how do you solve it?
I take 10 divided by 0.5.
No, cannot simply do like that. Right?
Oh,
Travel the same distance. They must travel the same distance at the same time. Then after that, the express train move faster. They will overtake already. After that, right? For uniform acceleration, the express train, you use this equation. So let the time be t, we have to catch up or to overtake. So distance traveled by the goods train equals distance traveled by the express. Traveled by the goods train is 10 times t. U is 0. Right? Express train initially is stationary. Half A is given there. And t squared. Right? T can cancel off. And then you can come. Right? You can find t 2 times 10 divided by 0.5. So it's 40 seconds. The answer is donkey.
oh.
Okay. Anything not clear?
Yeah, clear.
Okay. This is also a partial question. A small steel ball falls freely under gravity after being released from rest. Which graph best represent the variation of height of the ball with time? You can see it's not so simple, straightforward. Sometimes you have to apply your knowledge.
I put B lah.
D cannot be the answer. Because D tell
No,
you
B.
B. B B can also not be the answer because it is a straight line. Straight line tell you is uniform velocity. Starts from maximum height. Right? So it can be A, B, or C, cannot be donkey. Velocity increases. Right? How do you get the velocity? Gradient or slope equals to velocity. So you draw a tangent to the curve. Initially is 0, correct? Horizontal. Then it starts to increase. And maximum as it reach the ground. This one cannot be. But this one is tell you that the slope decreases. Right? Velocity decreases cannot be. When you drop the ball, the velocity will increase. A. Can?
Is it because there's acceleration?
It's accelerating. So the speed is
Oh, it's accelerating. 9.81.
This one you don't need to know 9.81, but it's 9.8 correct. But you must know that it's accelerating when you drop a ball.
Yeah.
So this is a distance time graph. So the speed is obtained from the slope or tangent, slope of tangent to the graph. Right? The rate tangent there, initially is it horizontal, 0, then start to increase, the slope start to increase more and more. Okay,
Okay.
okay, let's finish off with
20.
how about this
I
one?
put D.
Okay, a ball is released from rest above a horizontal surface. The graph shows a variation with time of its velocity. Area x and area y are equal. This is because, okay, so you must be able to read, right? You release the ball, free fall, so there is an acceleration. This is where it hits the ground, coming down. This is where it's going up. Maximum height. Then it's coming down again. Right? So you are taking downwards as positive, upwards as negative. This is going up, negative. Right? Negative velocity lah. And this becomes positive, coming down again. This is where it hits the ground again. Okay, this is because, right? All the four answer can be the answer. But the catch is area x and area y. Why are they equal? Right? All answers are possible. But the question asks about area, not the rebounds, area. Area on the graph for velocity is displacement. Downwards taken
So it's
as
D.
long key. Area,
Hey.
area is a distance or displacement. Okay with that?
Yeah, correct.
Good. How does the acceleration time graph look like? Any idea?
Going down, right?
What do you mean going down? Negative slope.
Negative slope.
It's a funny graph lah. Right? This part, uniform acceleration. This part, large acceleration. This part, uniform acceleration. Same, parallel. Right? This part also. This part is large also, but it's smaller than this part. Right? That's the initial velocity. There's a final velocity. Can roughly give that formula A equals to V minus U over T. So that's how the ground look like. Uniform, right? A short time where it impact the ground, where the picture didn't show you a short time. Roughly like that. Okay.
Okay.
Okay, let's carry on with our. I will send you the past year question. If you got time, you can try out the question lah. From 208 onwards to 2013. Lah. Okay, finding acceleration of free fall. Right? We can use simple pendulum method, but this is not what is required by the syllabus. Right? This is a formula we must know for simple pendulum. Then square it, you get this equation. Then we plot a graph of t square against L. And the gradient is 4 pi square over g. Okay, t square over L, you got a straight line passing through the origin. The gradient is 4 pi square over g. Then from there, we can calculate our g. Okay, this way you must know. Okay, so basically, to find acceleration of free fall, this is your cell, there's your switch, it's connected to a timer, and this one is also, the trapdoor is connected to a timer. So when you open the switch, right, It's an open circuit, so the magnetism goes off, so the ball drops. The timer starts. And when the ball hits the trapdoor open. Open means it close the switch, the timer stop. That's how it works. One thing about this method is that the timing is 0.01 second, 2 decimal place. Okay, measuring acceleration due to gravity. Right, this is our theory that we have gone over just now. Then you want to find G. Right, we just plot a graph of H against T square. So M is just half G. Measuring the time of fall at different height. Plot a graph of H against T square. Gradient is half G. So G equals to 2M. So all we need to do is find the gradient from the experiment, from the graph that we get from the experiment, and then from there we can calculate our G. And of course, we will know that when we do experiment, we never get all the points on the straight line one because of random error. So we get a point scatter, then we draw the best straight line. Right? Sometimes if we have a time lag or time delay, every point have a time delay. It could be the magnetism of the magnet did not disappear as soon as we switch off the circuit. So the magnetism is still there. So that's the reason why there's a time delay for every point. So the straight line shift to the left, right? That's systematic error. So it doesn't mean that we have to plot H against T square. We can plot, right? Can take the square root of this equation, root H square root of G over 2 times T. So we can plot root H against T. So the gradient in this case is just your G over 2. Okay? Any comment? Anything not clear? Usually I will record down. I will place it in YouTube. If you want to refer, you can refer to that. Okay, I will send you my PowerPoint in case you want to do some of the questions that we have not gone over. You want to check your answer. Okay, there are other methods. So if the rest you can read yourself lah. I think we won't bother to go over the others lah. The other thing that you need to know is this is called stroboscopic photograph lah. That means this one, the person is swinging the hand. It's done in a dark room. You use a stroboscope. Stroboscope will go off and on at certain frequency. So each time the light is on, you capture the position of the hand. No? Right? So that is your stroboscopic photograph. Lah. So the time between the ball is the same. Right? This is also a stroboscopic photograph or multi-flash photograph. Okay, I won't go into much detail. Right? This is a velocity displacement graph lah, for a ball thrown upwards. Thrown upwards, displacement start to go to 0 at maximum height of 20. Right? Velocity start to go to 0, and then after that it changes direction. As the displacement decreases again, the velocity decreases, but it's downwards. Okay, I let you read yourself. Hyperbola, need to recognize that, but that one is only in A2. This is how the parabola looks like. He's dropping a ball from a maximum height. He's throwing a ball outwards. Okay, so we have completed this one. Let's go to the second motion in 2-dimensional. I will send you the slide. Okay, are you ready to start the next part? Ready, ah? Okay, we go to projectile motion. I think it's about page 57. Right, this is in my Facebook that you can still find there. Right, some of my notes there. This is a practical paper three there. This one is a partial question for AS. We are now at the last part there. Describe and explain motion due to uniform velocity in one direction and uniform acceleration in the perpendicular direction. Right? Basically, that is a projectile motion. Right? It's called we call non-linear motion. That means it's not in a straight line. Okay. We are now on
my
page
internet
57. Okay with that?
page 57.
Page 57 in your note. Found that?
Yeah.
This is the part we are covering in the syllabus. Right? This is called non-linear motion, not in a straight line anymore. You can see that the motion is in a curve. Motion, sometimes it's called motion in a plane, no? Or motion in 2 dimensions. We will still use this equation of uniform acceleration. Right? No air resistance. We are not working with air resistance at the moment. So you won't bother about reference. You can use your own reference that your teacher suggests to you. Okay, so this is the syllabus that we are covering. Uniform velocity, one direction. Uniform acceleration, it can be going up, can be going down. To destroy a tank with a missile, what variable do the captain of the ship need to consider? Any idea? Any suggestion? Right, there's your ship is a ballistic missile. So the captain has to decide what are the variables he has to decide to destroy the tank.
Distance.
You need to know the horizontal distance, we call the range. Anything else?
Air resistance lah.
Air resistant, good. Anything else?
Radius of explosion.
Radius of what?
Explosion.
Radius, explosion, more of the range already lah.
Oh yeah.
Anything else?
Time.
Okay. You need to know the distance of tank from the ship. That's the range. The speed of the tank, whether it's stationary or not, or moving. And then you have to decide the speed and angle of the missile from that. And then you have to also consider the effect of air resistance. the direction of wind speed. So usually all this will be worked out by the computer lah. Okay, example of non-linear motion in a plane or projectile motion. That's what different name they are known by different name by different textbook. So example, air power rocket. Right? This is an example. Throwing a ball horizontally, throwing a javelin, firing a cannon. Right, let's review this troposcopic photograph. This one tell you that uniform velocity 10 meter per second. That means every 1 second increase by 10 meter. Right? Every 1 second, the first one, 0 time to 1 second, 10 meter. Another 1 second, at 10 meter is 20 meter. Another 1 second, we add another 10 meter is 30 meter, and so on. Right? So uniform velocity. So we use UX. UX is horizontal velocity lah, or velocity in the x direction times your time. That's how we find the horizontal distance. Uniform acceleration. Dropping a ball example, A is 10 meter per second minus 2. Right? We use 10 easier lah, easier to consider. But in the exam, you cannot use 10 lah. You have to use 9.81.
Yep.
Here, the velocity increases 10 meter per second every one second. That's why I show by that. Initially is 0. After 1 second, 10 meter. After another 1 second, sorry. Initially is 0. Velocity is 0. After 1 second, 10 meter. After another 1 second, 10 plus 10 is 20. After another second, 20 plus 10 is 30. Right? That's what it means by uniform acceleration. So in this part, we use our equation of uniform acceleration. Stop me if I'm going too fast. Okay, throwing a ball from a cliff horizontally. Think of the motion as a combination of uniform velocity horizontally. Right? That one. Right? Think of it that way. Uniform velocity horizontally and uniform acceleration vertically downwards from rest. That way. So at any time, right, for 1 second, you want to find the velocity, you just combine the vector. Right? 10 minutes time we are finishing off. Right? That's your velocity. 1 second horizontally. Horizontally doesn't change. Right? Vertically is increasing. So you can find the resultant after 1 second. And second, pink, combine the vector. Third second, combine the blue one, horizontal, vertical, to get the resultant. That's the resultant. And 4 second, the green one, horizontal, vertical, to find the resultant velocity. Right? This is a troposcopic photograph, or multi-flash photograph, where you drop the ball at the same time you send it horizontally. Right? So that's why they are having the same time. This is the same time, same height, same time, same height. Right? These are various apparatus we use to study motion in science lab. And if you have done that, study this in SPM Form 4. Usually we try to stimulate this. There's a ball there. Right? This one drop. We use the ruler to hit this ball. This one will fall vertically. This one will go horizontally lah. Okay, you can play with all this one if you have the time. Okay, so we are more interested in That's the motion. That's the acceleration. Motion is the velocity lah, usually. So we represent it as motion, right? We resolve this velocity into vertical, this deceleration, and horizontal, uniform velocity. And the weight, force is acting. Remember, we are not interested in air resistance at the moment. The force acting is the weight. Okay, so that is the ground. The black line is the ground. We call it x direction. And that is the velocity. Initial velocity. Usually in university, we don't use anymore. We use V. Put a 0 there to show it's initial at 0 time. Right? So it's projected at an angle V0 at alpha. Alpha is the angle of projection. Vx is the horizontal component of velocity. Vy is the vertical component of velocity. R is the range. H is the maximum height. So V naught X, right? Remember, naught is the time equals to 0, the initial horizontal component. Okay, so we resolve the velocity into horizontal component and vertical component. Okay, so what is happening here? Horizontal velocity.
Oh.
Yep. Anything?
No, I don't really understand this one.
This is the path. This is the path. The red one is the
Okay.
actual velocity. So we initially resolve it into horizontal component, vertical component.
Oh, okay.
Right? Horizontal component, remember, horizontally is uniform velocity. It doesn't change. It's always the same. It's always the same. Always the same. Right? At maximum height, it is not 0. Only the vertical component is decreasing. And at maximum height is 0. Then it changes direction. It's coming down. Right? It's increasing. And it's the same. Speed is the same, but it's pointing downwards. This one is going upwards, but it's pointing downwards. Any comment? Anything that's not clear?
So at the highest point, vertical component is 0.
Correct.
Horizontal
It's still there.
horizontal
There's no acceleration. It's
still
uniform
that
velocity. It doesn't change. It's always the
equals to
same.
the initial velocity, right?
Same as initial
Horizontal velocity.
velocity. Same as initial velocity. It
Oh,
doesn't
okay.
change because it's uniform velocity. Only the vertical one is the one changing.
Oh, yeah. Okay.
Okay, we will be cut off at any time. So we have to decide next week. You tell me which topic you want me to go over with you.
Oh, this one finishing already, is it?
Got 4 minutes left.
Oh, I mean this topic finishing already.
I have to show you some example. We have more or less covered it already.
Oh,
But I haven't show you an example. We will be cut off soon. So we can think of the motion as uniform velocity and throwing the ball upwards. So if it's projected at an angle, uniform acceleration vertically. Right? Projectile motion, that's our velocity. The broken line is the ground. We may have to cover that again next week. We don't have much time already.
okay.
So we are going to calculate maximum height, range, angle of projection. So theta is called angle of projection. That's the initial angle that you projected at. You projected the velocity at that angle, the object. U is the initial velocity, and that's the path. We call it, right? U is called velocity of projection. The path taken by the object is called the trajectory. So usually we resolve in component, vertical component, horizontal component. And then that is your horizontal component, U cos theta. Right? So that is uniform velocity. U sin theta is vertical velocity, uniform acceleration, vertical direction. So we are going to derive this equation. Right? So that's the range. Okay, that's the range that we want to calculate. So memorize, know how to derive. What we have done. We treat the motion in a plane of two dimensions as a combination of independent vertical and horizontal motion. That means we resolve it into y component, x component, and y component. And then we just calculate our x independently and y independently. And then at any time, remember it's a vector quantity, we have to find the component ux, vx, x direction, and then vy.
Oh,
Calculate the resultant vector.
can I ask, is Vx always using cos?
Ux, there's no horizontally, there's no force. So it's uniform velocity, always the same. Only
So
vertical,
Vx,
yeah,
horizontal I use cos, vertical I use sine.
depend on where you put the angle. If the angle is here, then correct. Right? Cos is always near to the angle.
Okay.
Okay,
Cos is always touching the angle, touching the line.
cos is usually the lower one, the horizontal, if this is the angle theta. Okay, you can ask questions since we got 1 minute, no point in carry on halfway. Anything not clear, you clarify. The next week we can start. And then tell me whether you want to go to dynamic or whatever.
What is the equation Vx plus Vy instead
This is a vector
of
equation.
Pythagoras theorem?
That means you have to draw out the triangle to find the resultant velocity. I'll show you next week.
Why don't you use Pythagoras theorem?
Yeah, we have to use Pythagoras theorem. But this is a vector equation.